Now let's summarize what we've learned so far about transformations to our parent functions in our library of functions. Okay, so when we make changes to the parent function f of x, and those changes are outside the grouping symbol, so that an example of that would be y equals absolute value of x plus 2, where we're adding the 2 outside the grouping symbol. And you may recall, since we're adding outside the grouping symbol, this is going to cause a vertical shift up 2 units. So changes outside the grouping symbol will cause vertical changes in the graph, and so that means you're going to be changing the y values. Vertical axis is the y values of the graph. Another example would be if you had y equals negative absolute value of x. When we multiply outside that grouping symbol by the -1, hopefully we remember that that's going to cause a reflection, a vertical reflection about the x-axis. Okay, so changes to f of x inside the grouping symbol are going to cause horizontal changes to the graph. So if we're changing it horizontally, that's the x values of the graph. So an example of that would be y equals square root of -x, where we're multiplying by -1 inside the grouping symbol. So if you remember, that's going to be a horizontal change, and that's a horizontal reflection, and if we're reflecting horizontally, that's about the y-axis. Another example would be if we added inside the grouping symbol, so square root of x plus 2, put the 2 on the inside. So now this is going to cause a horizontal change, and it's actually, remember, the horizontal stuff's backwards. It's the opposite of what you think. So you think you would shift to the right 2, you actually go to the left 2. Okay, now, here's an example of a function, and hopefully we can see that it's based off the parent function, absolute value of x, because you see those absolute values in there, and if you took off the 2 and the 1 and the 4, all those numbers, you'd be left with the absolute value of x. So hopefully we can see there's actually multiple transformations in this problem. Now, when there's multiple transformations to a given function, the order matters if they're, so here we have it, only if there are multiple vertical transformations or multiple horizontal transformations. So I'll show you what I mean. So in this problem, if we look outside the grouping symbol first, we've got a 2 on the outside of the absolute value. We're multiplying by 2 outside the grouping symbol. So hopefully we remember, when we multiply by 2 outside the grouping symbol, that's going to be a vertical stretch by a factor of 2. And then we look also outside the grouping symbol. I like to do the vertical changes together, the vertical stuff together, and the horizontal stuff together. We're subtracting 4. So that means we're going to vertically shift. So we have a vertical shift down 4. So those are our vertical changes. So we have to do the stretching before the shifting. And to help you remember that, you want to follow the order of operations. The 2's being multiplied, and then we're subtracting the 4. So multiplication comes before subtraction in your order of operations, so you have to vertically stretch before you vertically shift. So we'll write that up here. You want to always remember your PEMDAS, order of operations, please excuse my dear Aunt Sally, parentheses, exponents, multiply, divide, add, subtract. Hopefully you remember that. So since multiplication and division come before addition and subtraction in our order of operations, that means that we must reflect and compress or stretch before we shift. Okay, so back down to this example, we have the 2 on the outside. That's causing the vertical stretch by a factor of 2. Then we shift vertically down 4. Now I'm going to go inside the grouping symbol for my horizontal change. And remember, the inside the grouping symbol, horizontal stuff tends to be backwards. So we're adding 1. We think we would shift to the right 1. We're actually shifting left 1. So we have a horizontal shift, left, 1. So when you guys are asked, you may be asked to list all the transformations that have happened in a function in a given function. There are certain times when it matters, and it's only like in this case when we have two vertical changes. We've got a vertical stretch and a vertical shift. So in that case, we have to stretch before we shift. But other than that, the order doesn't matter. We could have done the horizontal shift first. We could have done the horizontal shift in the middle. But as long as we do the vertical stretch before the vertical shift.